Okay, so hello everyone. Thank you for coming to a JavaScript talk at a Java conference. I think it's a very wise choice. There are three certain things in life: death, taxes, and the fact that somebody has just published a new JavaScript framework today. What's even worse is the fact that front-end developers tend to rewrite their code bases over and over again all too often. So there are lots of tools out there we could choose from. So a question arises: when is it worth to invest to migrate our code base into something newer? The motivation behind this talk is to discuss fundamental design decisions behind the most important frameworks. You will not learn how to code in these. This is not a tutorial. Instead, we will focus on the trade-offs behind these design decisions. We will focus on weaknesses and strengths. And we will get a big overview of what we can expect from certain decisions. My name is Tomasz Ducin. I help developers create better software. I work as a consultant. The products we've worked on are used by very big companies, including Fortune 500. Apart from team project work, I also do developer trainings on front-end technologies. These include JavaScript, TypeScript, Angular, React, and last but not least, architecture. So if you're in need of consultancy or training, please feel free to reach out to me. So having coded in over 10 different front-end tool stacks, I came up with a conclusion that the most important difference between those is actually how does a framework know that something has changed, and now which part of the view should get re-rendered and when. This boils down often to pull versus push architectures, and an example we might get is if I have a dependency inside my code base, for instance, unit A depends on unit B, and now, if my framework requires me to explicitly define this dependency, then I know that. Or if it explicitly requires it, or if it could come up with this implicitly, then I could expect that if the value of B gets updated, then A gets re-rendered, but nothing else gets re-rendered because nothing else depends on it. However, if my framework is unaware of that dependency, potentially, it would have to re-render everything in order to guarantee that the view is basically refreshed simultaneously for the user. So, and this second approach might have a very bad effect on the performance. So these are going to be the most important differences. So let's start with something that we all know, which is lingua franca of the web, jQuery. jQuery was introduced in 2006, which was a long time ago, and jQuery is a tiny facade over built-in browser API. Its main purpose was to make it more convenient to use JavaScript and CSS at all. Nowadays, in 2019, using jQuery will not make you benefit at all because both JavaScript and CSS and the browser APIs has improved tremendously. So if you are considering using jQuery, you will not benefit more comparing to using just native platform. So let's take a look at a sample application in jQuery. If we hit the dashboard button link, we get the red box re-rendered. Now, if I click a link, I would like to have the tiles updated. Finally, if I type something into the search inputs and I hit enter, I would expect that both my tiles and the red box updates. Now, the problem with jQuery is that nobody actually keeps tracks of the state of the application. Nobody owns the state. So basically, all different pieces of the application would share a little bit of the state. And we know that if we have multiple sources of truth, then we might fall into trouble with desynchronization. Or if we want to synchronize them, we would have to do this manually, because jQuery will not do this for us. Another thing, if we have dynamic pieces of UI, as this red box, which would have to attach new event listeners, it means that we have a dynamic event listener. If we click dashboard multiple times, it would mean that potentially we would have to attach event listeners multiple times. So either we have to detach them manually, or we would have a memory leak in JavaScript. Moreover, if we attach an event listener to the dashboard button and we render this red box, then we have a tight coupling between them. There is no proxy, right? And of course, we could introduce a proxy, but apparently almost nobody did that because doing tight coupling is just the most straightforward, the easiest solution right here, right? Moreover, finally, if we have a bug in a jQuery code, it's very difficult to reason where did this bug come from just reading the code. Most often, we would have to end up doing a long debugging session just to go piece by piece, line by line, what is the state of certain pieces, because in jQuery, everybody could talk to everybody in all directions. So it's opened for quite a bit of chaos. So not only for the reason of browser APIs being a lot better nowadays, and also due to lack of architecture, there is absolutely no good reason to use jQuery nowadays. All in all, it ended up with this approach, which we don't want to carry on with. So the first most important framework in JavaScript ecosystem was AngularJS, introduced in 2009. It introduced two very important features into JS ecosystem. The first one was dependency injection. So let's take a look at a few lines of code here. We could define a module that has a dependency on another module. We could define a service, the department's model service that depends on HTTP service and on a base URL constant, which is defined somewhere else. Finally, we could define a user page component that depends on the scope, user context, and department's model service defined just above. There is nothing special or peculiar about this dependency injection. However, it is very important that AngularJS team introduced it because back then, JavaScript had no built-in modularity, no built-in system to declare dependencies. So basically, front-end developers ended up adding lots of script tags. So it was inconvenient for not only adding multiple script tags, but also, what was even worse, maintaining the order between them. Even if I took my application code and squashed that into one file, being it concatenated, uglified, minified, doesn't matter, I still had to care about the order, which was really very difficult to cope with. So basically, what dependency injection did was I could add those script files in any order, and only in runtime the right dependencies would get resolved, because here I just define what are the dependencies. So dependency injection solved a very big issue. It's not such a good idea to use dependency injection in Angular 2+, but we will get to this later on. At this time, it was a very good idea. The second feature of AngularJS was introducing two-way data binding. Basically, I do have my view, and I have my model. Model is just some JavaScript objects that live in RAM memory. So if I want to synchronize model with the view, I just get the value of a variable and display it. Or if I want to do it the other way, I attach an event listener with just the famous ngModel directive, and I want to update the value of the input into JavaScript memory. So I could do it one way, or the second way, or both ways at the same time. So it was very convenient for developers to write very little code to get lots of stuff achieved. AngularJS is super performant for developers to prototype applications. But the engine that fueled this two-way data binding, and actually all data bindings, is not the best, let's say, piece of software design. So it's called the digest cycle. So basically, if I want to update model to the view or view to the model, I create a single watcher for every piece of this update. An AngularJS application is structured with components, so we can see that there are components here in this application. Each box is representing one component. So one component or directive will have multiple watchers. So when there is any change in the application, just anywhere, it's important, anywhere, then the whole application would have to re-render. So it's a lot of work to do. So basically, the root component would have to run all the watchers, see if the new value is different than the previous value, iterate through all the watchers, then iterate through the tree of components, iterate through all the watchers of this component, and again, and again, and again, again, and so on. So I would have to re-render the whole application. Finally, it might happen that I have a service that shares some memory, and I would like to update a value of the service that another component depends on, and this dependent component was already rendered. So I would have my guarantee of updating the view broken, right? So I would have to go through the whole cycle again. And if it happens that at the end of this digest cycle there would be yet another update, then I have to go through this digest cycle again and again. So you can see how killing for the performance this algorithm is. This was AngularJS. It was not meant to be a production-wise application system, at least not such big systems as we have nowadays. The problem here is that when we were updating the values of the services, it was a pool-based approach. So basically, we were updating just a property, and the property does not let anybody know that it has changed, right? So AngularJS does not track what should I update if a certain piece of my application updates. So in order to guarantee the freshness of the application, I have to update everything, because everybody talks to everybody in all directions. So the less framework knows about my application, the worse performance we can get. So a completely different approach has been chosen by the React team, which suggested something completely different, the virtual DOM idea. But before we dive into it, let's take a look at how React components look. By the way, how many of you are using React? OK, some of you, maybe 20% of the audience. So just a quick reminder. We create a React component just by creating a class that extends React component. There is the most important render method internally. It has to be implemented, and the render method returns some piece of the view, some markup. What is important? It's not being injected into the DOM yet. What render returns is a virtual representation of the view, and this is a very complex inversion of control technique that React is going to work on a virtual representation of the DOM a lot until it actually touches the DOM in order to get better performance. We will see this in a while. So a component will often have some state. So what React changes is React introduces ownership of the state. It has to be explicitly said that this component owns some state. It will be very important in a while. Our example component has a button on click handler. So basically, when we click the button, a function will be called, and this function calls this.setState. SetState is the gatekeeper of React. This is a method that tells that the state of this component has been updated, so potentially the view needs to get re-rendered. So whenever we update the state, React will have to re-render this. Still, we are in the virtual phase. So we will re-render, and we can see that this .state.count has a new value already, so it will create a new representation. So not only the current component have to re-render, but potentially this component might have child components, either one or multiple children, that may depend on its state or not. In this case, child component gets a count property called prop. It gets some piece of data from the parent. And also, this means that not only this component will re-render, but also all its children recursively. So the improvement that we have here is that not all application will get re-rendered, but when a certain piece of state gets updated, this component gets updated and all its children, but nothing else. Neither the siblings nor the parents. There is basically no need. React introduces one-way data flow. So now, it's not that everybody can talk to everybody. No, we introduce one-way data flow. The data will flow only from up to down. There is only one direction possible. So We have seen a class component so far. A class component is basically an object, so it has an identity. It resides in RAM memory, which is pretty obvious. And we have function components that do not have any identity. There is no this, so there is basically no piece of memory that this component would reside in. React introduced view as a function approach, so that for given props, I would like to have some markup. I would like to get some view. So it's making as little code to define our view as possible. React is probably requires us to write the least code comparing to, for example, AngularJS and Angular. These two are equivalent. There are some additional features like React hooks that I'm not going to cover in this presentation because it could not basically fit into one talk. So, React ecosystem, React community came up with an idea of component architecture, which basically introduces a distinction between smart and dumb components, or being more politically correct, container components and presentational components. The distinction is based on the fact that presentational components are responsible for how the component looks like, so just HTML, CSS, this kind of concerns. And the container is responsible for doing the whole application logic, which is doing web services calls, managing state, managing user data, cache invalidation, and so on and so forth. So if a presentational component has a button, and this button is clicked, this component should not know what is its purpose. So basically, the parent, the container component, would create a function that would have encapsulated call to this.setState, and it would pass this function. It would be a closure. It would pass this function into the child. So, and the child will basically get a function. It's like command handler pattern in object-oriented programming. When the button is clicked, I call a function, but I don't have any idea what this function is doing. So it's just a very nice separation of concerns. Component architecture makes so much sense that it's used nowadays in React, AngularJS, the new versions, Angular, Vue, and so on and so forth. It's a very general approach to do modern frontend nowadays. So let's get back to re-renders. As in all platforms, there are operations that are cheaper and more expensive. In backend programming, we know that the operations on processor are the fastest because everything is already in the processor. Operations on RAM memory are still quite fast, but if we want to process something from files, we would have to open these files, read the data, right? And we have to wait on I/O operations. And the worst ones are network operations because not only we have to wait for them, but they're also prone to network fallacies. And similarly to the expensive operations. In the browser, the most expensive operation to do is to manipulate the DOM. So for instance, if I want to add a DOM node or remove a DOM node, or I add a class or remove a class, potentially I would have to recalculate all the coordinates of all the divs, spans, articles, p, divs, and so on. And afterwards, I would have to repaint the whole application. So the thing is, I have to do it anyway because there is no way to update the view for the user. But the thing is, I would like to do the manipulations on the DOM in the shortest period of time that is possible. So the idea behind React is to collect all small atomic changes, and when I have already collected them, just walk into the DOM, do pick, pick, pick to do the changes, and go back, so that there is only one recalculation of the DOM. Thanks to it, the user experience is a lot better because the application is fluent. So let's take a look at this. This is a simplified structure of the DOM. It's just a tree structure. We have a div with body with two divs and a span and some more elements. You might be familiar with the same concept that looks more kind of like this. Right? That's just the tree structure of the DOM. So now what React introduced is so-called virtual DOM. We still have the DOM in place, but we want to encapsulate some pieces of the real DOM with the structure of React components. So we have one component and the second component, and yet the third component, their parent, is encapsulating all of them, and the parent has to be mounted somewhere. It might be a div, it might be even the body tag. Finally, virtual DOM is not yet the real DOM. It's just a JavaScript object representation, which we'll see right now. So you might be wondering, how does React work? How is it written in JavaScript with this funny syntax of HTML tags put here? Actually, it's also a nice example that the good practices of yesterday are tomorrow's anti-patterns. Some time ago, there was an approach to write non-obfuscated JavaScript so that JavaScript code is in JavaScript files, not in HTML. Similarly, CSS resides in CSS files, not in HTML. And that was a good practice some time ago, but now React breaks it in one direction, Angular breaks it in another direction, so it's not a good practice anymore. Anyway, JSX is being transpiled down to raw JavaScript with a very, very simple transpilation process. Basically, whenever I have a single, there is a delay. Whenever I have a simple tag, it's going to be transpiled down to one react.createElement call. So we have one div. This div has an heading 1 child and another emg child. So react.createElement returns just a JavaScript object that represents this virtual piece of DOM. It's just a JavaScript object with some properties. Now, what is important? This is already pure JavaScript. So if we want to do static typing, we might just use TypeScript for this reason, right? So we have, with very little effort already made by the TypeScript team, there is not only JSX, but also TSX. Thanks to this, we have statically typed templates, which is a phenomenal improvement for Frontend, because now we will get all the typos during compilation phase. Not only all the typos, but we would also know that a string is not an array, so certain methods are not available. We would not get them in runtime. We would not get some obfuscated JSP or JSF error messages. We would get plain TypeScript error messages, which is super cool, because if I'm using a simple template engine which is close to the native language, then potentially it's very easy to adapt TypeScript. And React's support for TypeScript is very, very good. Actually, it's better than Angular, which template engine is a lot more complex. It's just a lot more far away from JavaScript, so that it's just not easy to use TypeScript for this reason. So, when we hit render, we are actually retrieving an object that represents this virtual piece of memory. Now let's get to the heart of React, the diffing algorithm, which is also called the reconciliation. So, as we have initially rendered our page, we get the tree at the top that we can see. So this is just a representation of what the view should look like. Now, at some point in time, it gets rendered into the DOM. So there is basically a snapshot to the visual part. At some point in time, there would be a this.setState update. And at this point, all the components would have to re-render. So we would get another representation. What React is doing in the first phase, the render phase, the virtual one, it's comparing the two trees and creating a sequence of changes. As you can see, this div item here, it's creating a sequence of atomic changes that has to be pushed. It has to be just injected into the DOM. This is an asynchronous process because during this diffing, some interactions of the user or of web services might happen, so I would have to collect some more, right? It should not be synchronous because there would be multiple DOM updates. If I make it asynchronous, I could just collect them asynchronously. So finally, when I have collected all the changes that I need, then I can just go to the DOM, do the updates in a very short period of time, and basically I'm done. And this is the commit phase. So this is a tremendous improvement over jQuery and AngularJS. So now, we have already spoken about one-way data flow in React. Going back, the idea is that the state or the props of components will be pushed down to all the children. So if a component state changes, then we have to re-render it, right? Potentially re-render the whole tree. So now, what was a state of a parent becomes properties or so-called props of the children, and now this component also has to render, potentially propagate some props down to the children. So this is just the idea. As you can see, if I would update this component, there is no need to update another piece of the tree. You might be thinking, where does the React name comes from? What is actually reactive in React? So the answer is pretty simple. The inversion of control technique behind React makes me as a developer only responsible for declaring what the view is, how it looks like, but I don't ever care about when I should do it or which part of the view I should re-render. So I don't care about this. React will do it for me as long as I use the API to update the state. So basically, as long as I'm doing this.setState or hooks, I'm safe. Now React reacts to state changes with updating the DOM. That's the idea. You might be thinking, well, if a component state changes, it passes some props down to a child, and if it happens that a child is receiving the same props over and over again, still in React, view is a function. If we have class components, still we are calling the render method, so still a view is a function. If I get the same data to a function, I should expect the same result, right? Pure functions and all this kind of functional programming stuff. So basically, I would like to have a functionality that if I get the same props over and over again, there is no need to re-render, right? And this is what I can use pure components or memo components for. So if I find out that the previous props that I have already re-rendered are the same as the new props, I don't do anything, right? So there are no new re-renders because I have already done this job. This is based on immutability. It's very straightforward. If I have a functional component, the only thing that I change is I have to wrap this component with a react.memo call. That's all I do in functional components. And in class components, all that I do is to change extend react.component with react.pureComponent. That's basically it. Now comes the important part about immutability. If a component receives props, and it could receive quite a lot of these props, if I had to compare two objects, which are pretty big, I would have to compare all the properties recursively, and if I do it often, and in React I re-render the components pretty often, this would be pretty heavy in terms of performance. So what I could do is to use a lot more memory so that each change of an object will create a new snapshot. Right? So I'm doing immutable data structures. I'm using significantly more memory, but thanks to it, if I compare two objects, I only compare their reference. And there is basically no faster operation possible to compare two big objects than just to compare two numbers, two addresses of memory. So this is how we achieve, thanks to bigger consumption of RAM, that's a trade-off obviously, we can improve performance. So, when speaking about React and Angular, it's very often discussed along with state management. This is probably the most hot topic in JavaScript ecosystem right now. So basically, either some piece of state might be privately owned by a component, or it could be shared across a bigger piece in the application. The most important player here is Redux. If we didn't have Redux, and we would like to propagate a change from a child component, we would have to call the callbacks via each step to reach the parent, and then the parent would have to propagate the change down to all the children. So there would be lots of code required. The maintenance of this would be also very expensive in terms of our development, because if there would be any change, we would have to touch lots of places. So the trouble we have here is solved by Redux. It's just going to be a proxy that would be a shortcut across different components. So one component would dispatch an action. An action is basically an event. Something has happened. For instance, I changed a country from a drop-down. It's not Poland anymore, it's Czech Republic. I am letting Redux know about this, this change. So lots of the state that has been private to a component now becomes part of Redux store. Redux is owning lots of the state that used to be part of components right now. So Redux is holding a lot of state, and it receives actions from some components. And now comes the heart of Redux, which is reducers. For a given state object and an action object, calculate a new state object, which is pretty trivial. Reducers have to be pure functions, blah, blah, blah. I'm not going to cover Redux tutorial. So basically, when a new state object is being calculated, certain components are being notified about the change. So again, we know which parts do depend on this item, and potentially all its children also would have to get re-rendered. So we are making a shortcut. That's one thing. Another thing is it's not an observer pattern. It's more kind of a pops-up pattern that still, it's an observable, but the two components, the publisher and subscribers, do not know about each other. So they are they're loosely coupled between each other. So it's easier to work on this and easier to refactor. Now, Redux is centralized. It said that it has to be a single source of truth. This is a singleton. As long as in backend systems, singletons are considered an anti-pattern because it's a lot more difficult to leverage scalability, to put a system in a cloud if we have lots of singletons that share state. In frontend, it's not a problem because if we execute an application, we usually do it on one screen. We don't run one application across various screens, right? It's just one screen, one browser tab, one thread, right? So having a singleton is not a problem. Actually, having a centralized source of state source is very good because there is no problem with desyncs, and this is why Dan Abramov, author of Redux, decided to go this way. So another feature of Redux is EvenSourcing. So basically, Redux keeps track of all atomic operations that has happened, all the actions, all the events. And I would like to demonstrate a small demo of its capabilities. So this is to do MVC application, a pretty famous approach to compare various JavaScript implementations. So let's say we, on our to-do list, we want to come to Krakow, to enjoy Devoxx PL, of course. And now, well, we came to Krakow. We are already enjoying Devoxx. And let's say I want to keep my list clear, so I clear completed items. And now I would like to learn about something that is cool and popular in Java community. Let it be Kafka streams, I guess that's the thing right now. And to listen about JavaScript architectures. So there has been some actions that I have dispatched. And now what Redux is capable of is doing lots of very useful operations within Redux DevTools. So first of all, Redux keeps tracks of everything that has happened. So it's like keeping a database of all the events that has happened in the application. Like, it's not a persistent database, but as long as I'm running this application, I do have them in state. What I can do is reason about the application using time traveling, so I can see how did I get to the point. No system before Redux was capable of doing this. What EvenSourcing allows me to do is, for instance, what we had in Back to the Future movie. I hope you all know this. When Marty McFly came back 30 years ago to the times of his parent, he has given the almanac to a bad guy, and there was a new branch of history, right, that arrived. Redux is also capable of doing it. I could see what would happen if some action has not taken place. So if I didn't clear the marked items, what would the history be? So let's take a look how this would look like. It's just not cleared. Or for instance, if I have cleared, but I didn't, let's say, mark enjoy Devoxx conference as done, because Devoxx is still taking place, so I'm still enjoying Devoxx. So I could see alternative branches of history. Now, let's say that we do have a bug in this application, and I'm submitting a bug to some bug tracking system. I should declare what are the steps to introduce a bug, but additionally, I would download what are the actions here. So I'm basically downloading a JSON file, just a JSON file that would include all the actions. And now, when I submit a bug, another developer would open my application, and that developer would simply upload the state.json, and voila, the person knows what was the state, how did I get there? So it's a lot easier to reason, not to mention that this developer could see what would happen if, and so on and so forth. Imagine all the situations where you came to an old legacy system, where you had to fix bugs that were introduced by some developers who have left the company lots of years ago, right? And there is nobody who would know how does this code work. Now, having everything in place, it's a lot easier to reason. So we covered time traveling, we covered alternative branches of history of what happened in our application. One more feature of Redux I would like to discuss is hot module replacement. So basically, the thing is, if I have to click all these events and I would have to modify how does Redux interpret the actions that have been dispatched, if I get my application reloaded, then I lose all my state, and I don't want to lose it. So what I can do is to tell Webpack that if you change the reducers, please do not reload the whole application, only inject the new reducer, so inject the new way that you interpret what does it mean that an action has been dispatched, but please leave the whole RAM memory and leave all the actions in memory as they were. So we might, for instance, change that instead of having just a text string, we would like to have text to uppercase, and without any additional workload, we get the things. Or if we wanted to do something more like, James Hetfield style, yep, we can get the same things over and over again. Yeah, so hell yeah. Now imagine that we are working in a banking system, and there is a bug in banking scheduling transfer process. It's a multi-step process. First, we have to open a model. We define a model window. We define whom do we want to pay, when, how much, etc. In the second step, the system asks us, are you sure that you want to pay this amount to this person, blah, blah, blah. In the third step, we need to validate the transfer with a token or an SMS token. And finally, in the fourth step, the final step, we get a confirmation your transfer has been correctly scheduled. And now imagine you have, this is a situation that I had some time ago in a Polish bank, that I have an error in the fourth step, and I am not receiving real SMSs, but I am receiving some kind of mocked emails that not only I receive, but the whole IT department receives. So that was pretty cumbersome to use. Now, what I would do in this case is I would basically click through all this process to the final step once, and then I would only modify the logic of the reducer. This would make it a lot easier. So this is hot module replacement in Redux. So having said that Redux is pretty powerful, I need to be fair and to say that this EvenSourcing is really, really powerful, but it comes at quite a big cost. So we have to implement constants, we have to implement action creators, reducers themselves, we have to learn about functional programming patterns. If we want Redux to be performant, we also have to implement selectors to leverage immutability. If we want to have more complex application flow, we would use plugins for Redux called middlewares. The most important ones are Redux Tank, Redux Saga, or Redux Observables, the epics, reactive ones. And last but not least, finally, we would have to implement a bridge between Redux and specific frameworks components, like React Redux or some other implementation. So there is quite a lot overhead that we would have to do. So we can get a lot using this front-end EvenSourcing, but the price is pretty high. Now there comes a question, what if I would like to get the benefit of not drilling this application down through all the steps, but I am not sure if my application is big enough or complex enough that I do really want to pay the price for this EvenSourcing. My choice of preference for small applications or applications that I don't know if they will grow much is to basically introduce a small pub sub for small piece of the state anywhere. So basically, this could be a 2-liner, 3-liner. So if I implement it very fast, I don't regret removing it very fast because there was not much invest, so I can basically remove. But the thing is, these components would be already customized to subscribe to some source of data. Obviously, if the number of these pub subs will be growing too much, then I would consider replacing multiple single topic pub subs with one event bus. So there would be just one pub sub, but it would handle multiple topics. So it would not be that kind of chaotic. Like the order of architecture in some way based on the fact that I should not necessarily make the decisions up front. I do not know if my application is going to grow big or not. I would like to delay the decisions. So this is an example way to do this. And if my application grows very big, and if I'm failing that there would be more developers coming, or this application would last for many years from this point, I would decide to go one step further to increment this and basically to replace this very tiny layer of a pub sub with a whole reducer. So it's not either or. It's not that I would have to throw out a lot of implementation. No, I just do an incremental change. I don't have to start with Redux. A very good implementation of both a single topic pub sub and an event bus are RxJS subjects. Basically, RxJS and RxJava is pretty much the same concept, the same stuff. The differences are only in the syntax and the constraints of the platform itself. For instance, JavaScript is single-threaded, and so on and so forth. So let's go forward and talk about Angular. Angular has continued with many decisions from AngularJS. Some of them are good ideas, some of them are not, including dependency injection, two-way data binding, and so on. Angular also leverages lots of ideas that come from React itself, for instance, smart DOM components, component architecture, and so on. So I would like to start with a collision between dependency injection and lazy loading. So at the times of AngularJS, our applications were not as big as they are today. So today, we don't want a user to load 10 megabytes of an application because it's just too much, especially for mobile devices. So we would like to download only the main page or the main piece of the application, and only if I get to some specific tab in my application, which very few users are doing, then I would asynchronously load this module into my application. Now, how this falls in conflict with dependency injection is that dependency injection would like to know what are possible classes, what are possible instances that I would like to use. And in server technologies like Java or C#, it's perfectly, or Python, whatever, it's perfectly fine because if I start an application, I do have all the files locally. So there is no problem to basically read the files, right? Bootstrap might take longer, but the runtime of the application is important. I do have access to all the files, but if I lazy load my modules, and I do it very frequently in modern frontend, then I don't have access to the source code of the whole application. So how can I declare dependencies over the things that I don't have yet? So this falls in conflict. So if I want to create boundaries of what is possible for the dependency injection container to handle, I have to create yet another boundary for this. And this is unnecessary. That's the key point. So JavaScript, since ES6, introduces import and export keywords. So we have modularity built into the platform, which is very useful. So this is the reason, like, There was no import and export, and this is why AngularJS introduced the dependency injection. Now, once it's built into the platform, it's not needed anymore. Moreover, JavaScript has NPM, Node Package Manager, which modularizes not only single files, but the whole packages, just like Maven in Java. Finally, AngularJS, unfortunately, introduces yet another system of modularity, which looks kind of like this. We declare a module, ng module, which has declarations of components and filters, pipes, and I could use. I could import another module so that I could use their features. If I want my component or my local pipe to be available in other components, I have to export it manually. Sometimes I have to go down into some Angular black magic and declare some provider. This is one of the most convoluted parts of the framework. And finally, for the main module, there is a main view that bootstraps the whole application, the root component, which is basically the bootstrap. So this information are important, but the problem is that I do have to import and export them on native JavaScript level anyway. And if I'm doing multiple products on some kind of shared component library, I also have to handle NPM packages. So it's not that Angular layer replaces or works on top of the native modules. I have to handle all of them, not to mention that this is one of the most overcomplicated part of the framework, unfortunately. So at the top, I would have to have all the imports and exports anyway, so basically I'm doing this stuff twice, at least twice. So what I could do, in new JavaScript, I can export a class, obviously. So this is what happens in Java. In a class, in a file, I can have a class, which is basically automatically exported within a package. I don't have to write the export because it's exported by default. In JavaScript, I have to do it explicitly. I can export an instance. This is how I can make an instance shared across the whole application, because if multiple files import an object, this is going to be the same object. Moreover, I could export a primitive, an object literal, a function that returns a fresh literal, or I could even enforce that when I call this get literal singleton, I would like to have the value returned by that function, and it's also going to be cached. So if I call it multiple times, I call it lazily, I am guaranteed that there would be only one instance. So this is a very thin alternative to dependency injection, which actually React uses. You might say that, okay, but your tests are going to be flaky, because if you share the same instance for many tests, then those tests would be dependent on each other, which is very bad in terms of tests. So no problem. Instead of exporting a single instance, which an application is going to use, you can additionally export a function that will produce a new literal or a new object whenever you need it, so that each test can have fresh data. This is a lot simpler, and this is pure JavaScript. So if you know the language, you're good to go, and you don't need to go through any additional black magic. So I have covered this kind of this piece of flaky design in Angular. Now let's take a look at how a component is structured. So basically, components in Angular are always classes. There is no API for functions. So Angular is a lot more imperative than compared to Redux, which is declarative. I also have so-called TypeScript decorator. A TypeScript decorator is like Java annotation or a C# attribute, basically the same concept. I have some metadata there. The most important metadata is the template. So this template looks more or less pretty simple, but I have some custom syntax there, like ngIf, ngFor, which does not translate to JavaScript that easily. And unfortunately, Angular templates are not capable of using TypeScript out of the box, so there has to be an ng factory, a custom implementation within Angular that would compile these templates and do lots of black magic stuff that would build some TypeScript on top of that, so it's a lot more complex. We don't get TypeScript support so easily. We do have them, but the error messages, for instance, are quite a lot obfuscated. So instead of props in React, we have inputs. They play exactly the same role. And we have outputs. In React, a parent component was pushing a function to the child, so whenever a button is clicked, the presentational component will call the function, being unaware of what it does. Angular takes a different approach. This component is going to emit an event, and potentially the parent would subscribe to this event. This is all fueled by RxJS. So basically, we have an output, which is an event emitter. It's an Rx subject. Basically, it's an Rx subject. So when this button is called, then we are emitting the value, and we modify the internal state to some degree. So these are Angular components. Now, important piece of Angular is its chain detection algorithm. So in AngularJS, everybody was talking in all directions, and the problem was that the control flow in AngularJS was pool-based. So basically, if I depend on a service that has a property, I don't know when does this property change its value. And that's a problem, right? So we want to invert the control to make it better. And now chain detection in Angular bases on RxJS reactive streams. So basically, instead of having a variable, I'm going to subscribe, so I know exactly when the change had taken place. But I don't know where it took place, and we'll see this in a while. If I have a component that is emitting an event, and this event has yet another event as a consequence, and one more event as a consequence. This could be events, or this could be a chain of promises. I believe you have seen a chain of promises like do http.get, .then. So another step, another step, another step. The limitation of JavaScript is that through all these steps, JavaScript is losing the context of who have called this. For instance, a promise would push the return value of the promise to the next step in the chain, but it would not push any additional information, for instance, who initialized the call. So we know what has happened, but we don't know who has started this thing. So Angular introduces what is called Zone.js. Zone.js basically wraps all async APIs in the browser, events, promises, async await, Rx streams, and so on and so forth, with injecting the information about who started all the thing. So basically, when I'm done, I know who was the initial caller of the thing, so I know whom to update in the end. So again, we are trying not to render the whole application, but only a certain part of it. So that was a very good idea. Another good idea was to introduce TypeScript as the source of Angular frameworks itself. So Angular was the first major framework to introduce TypeScript to a massive scale. Nowadays, all major frameworks support TypeScript, React, Vue, Angular, AngularJS, but Angular 2 was the first one to introduce it. So even though the framework could benefit from it slightly more, the community has tremendously benefited from this because TypeScript got a lot more popular thanks to it. You are Java developers, so I don't have to convince you that static typing is a good idea, especially in big projects or projects that will last for a long period of time. Another good idea in Angular was to introduce RxJS reactive control flow to the system. Basically, in interfaces, like we could have interfaces that have really big forms that there is nothing going on. In such an application, I would not necessarily use RxJS because it would not make me benefit. But if I have an application that data is changing in real time, or I have even forms that are very interactive. For instance, if I check a checkbox, then some piece of the form will show up. If I change a select drop-down item, then something else would change. I could have forms that I could play with. So with RxJS, I can basically define what are the reactions between the items, and I exactly know when they happen, because instead of having a variable, I will have an observable that will basically let me know when it happened. So we'll take a look at this right now. I would like to start with reactivity from imperative code to compare with. So this is the easiest piece of code that I think I could illustrate reactivity. I want to exchange my local currency to a foreign currency, for instance, exchanging Polish zlotys to euro. I have a rate variable, I have an amount variable, and I have an exchange variable that declares that it's amount divided by rate. Now, if I change the value, the exchange has an initial value, obviously. If I change the value of rate, we can see that exchange is desynced, right? I have to update the value myself. So you could think like that's so obvious, right? But the problem is, if I have an application that has that doesn't have 3 variables, but it have 300 variables or 3,000 variables, more likely, then it's very easy to forget about this kind of dependency. So what we actually have here is that exchange has an invariant that exchange should always reflect amount divided by rate. Now, if any of these pieces change, I have to update the thing. And the problem is, this is my responsibility if I am coding imperatively. So this is the benefit that I get from reactive programming. So this is a pseudocode. This is not real RxJS code. This is a simplification. But basically, instead of having variables, I define observables. So a snapshot of a value that will let me know when it changes. So I have an observable of rate, observable of amount, and I have an observable of exchange that will subscribe to amount. It will subscribe to rate. If they both have an initial value, then exchange will also have an initial value. The thing is, if I change rate or I change amount, exchange would recalculate because it knows when its sources have pushed a new value, so it would also propagate a new push of its own value. So the heart of reactivity is I've got this invariant that is basically put natively into the platform. If I define it once, I never ever have to care about updating the value manually. And in big code base, this really helps. The cost of this is learning reactivity, which is not that easy. In real code, we would have to do amount.combine latest with rate, so basically get the latest value of amount, combine it with the latest value of rate, and whenever we have any change, basically run this function. Combine latest is one of RxJS operators. There are around 100 or 130, depending on the convention, different operators. So there is quite a lot of them to learn. And operators is only the first step of learning reactivity. So there is quite a lot to learn, but there is also quite a lot to benefit from. So, I could say that reactive extensions, whether it's RX.NET, RxJava, RxJS, and so on and so forth, reactive extensions redefine what a variable is. Instead of having a variable which is a snapshot of a piece of memory, I get an observable stream that will let me know when a value has changed, so that this invariant of my application logic is basically baked into the platform. And it makes it a lot easier to use. So, the key takeaways from this presentation. First of all major frameworks support TypeScript, so please use it. Whether you're doing AngularJS or jQuery, the old ones, you'll have very good typings, despite the fact that those frameworks were not written in TypeScript. React is also not written in TypeScript. React, Vue, and all these tools will make you benefit a lot. Redux is very powerful, and so is EvenSourcing. Also, it has support for all the frameworks. We could use Redux for React. We could use NGRX for Angular, which is absolutely the same thing, but is more reactive. We could use Vuex and all other similar tools. However, implementing this comes at a big cost, so if you're unsure if you want to make that investment, go with a PubSub implementation. Now, if you want to choose a framework, that's a debatable topic, but if you're not scared of functional programming, if you're familiar with functional programming, React seems to be the state of art of Frontend 2019, according to lots of surveys. You write potentially small code that would be very performant, and it's very clear. What is nice in React is that you don't have to learn many things, but if you forget something, you can deduce it. You can think it out. In Angular, more you have to learn by heart. Things are not that easy to deduce. You basically have to go through documentation over and over again, and you have lots of custom syntax. But if I had a team of Java developers who are very proficient in object-oriented and not necessarily proficient with functional, I would go with Angular, because going React and Redux would force the team to first learn functional programming for a few weeks or a few months, and then to become productive. Finally, if I find myself in a situation where I have multiple code bases written in various frameworks, there is no need to rewrite the code base to make it in a single, let's say, tool stack. We could leverage microfrontends, and that's a very broad topic, and apparently there is another talk about this. But basically, I could go with either iframes or bundled applications with a host app that when I click one link, a new application would be bootstrapped, either linked via iframes or basically bootstrapped with a bundled Webpack application. I would be bootstrapping this application, I would be destroying them, and I could, basically the host app would collect events from the sub-applications. All in all, this is a separate topic, standalone topic, but I don't have to rewrite these things. Go and learn about microfrontends so that you don't have to rewrite the code bases. So that was quite a lot of stuff, I guess. That's all I've got. Thank you very much.